Welcome to day 3 of Everybody Codes. Today we're continuing with the story from yesterday. We have the completed breastplate that we forged in the blacksmith, and looks like we need to do something to do with shipping supplies today. So we're given a list of numbers representing crate sizes, and it seems that if crates differ in size, then the smaller one can be packed within the larger one. So basically, any two crates that have different sizes, you can put strictly smaller crates inside strictly larger crates. And so we want to find the largest possible set in terms of the total size of all crates. And so if we have a list of crates, then we can pack them sort of Matryoshka doll style and put a bunch of crates consecutively within each other. So this problem is fairly straightforward. What we can observe is that if we have a crate and a set that already exists, if the crate has a size that doesn't match any of the crates already in the set, we can always fit it in. So for example, if we had a crate of size 6, we could put all of the crates within the one with size 5 all into the crate of size 6. Basically, we put this crate into the one with size 6, and then we put that inside the crate with size 8. So we can always fit other crates within the middle, which means that really all this is asking is, if we remove all the duplicates, what is the sum? So here we have 2 crates of size 10, so no matter how we do this, we can't put both of them in one set, because there's no way that we would be able to package both crates with the same size, because they cannot fit inside each other. So really what we're asked to do here is to just deduplicate the set and then take the sum of the sizes of crates. And so in Python, the set data structure works perfectly for this. Sets are an unordered collection that cannot have duplicate elements. So if we have a set, we can add elements, and the main advantage of this is that you can check whether an element is within a set much faster. So if you have a list, checking if an element is in a list requires you to loop through the whole list, but with a set, there are optimizations that make it much faster. But something else that's notable is that sets are unable to contain duplicate elements. Rather than being an ordered collection of items, it's basically a data structure that only cares about whether something is in the set or not in the set. It doesn't have a concept of how many times it's in the set. So what we can do is take the sizes as the input split on commas, and then map those all to integers, and then we can just take the list of sizes and convert it into a set. What we can do here is simplify this operation. So map in Python 3 returns a map object. So if I do this, for example, you see that I get a map object. So if we want to do anything with that, we have to convert it into a list, which will give us a list of numbers. Rather than converting that list to a set, we can shortcut this, and I don't know what's going on with my terminal today. Just pretend that makes sense. Something's wrong with the terminal here. Yeah, if we just convert the map object into a set directly, that works just fine. And so then we just want to take the sum of that. So this solution actually ends up basically just being a one-liner. You don't really need to store the intermediate variables. If you want to make it make a bit more sense, you can do like you might do something like this, but I honestly find the first one to make perfect sense as well. So up to you how you want to represent it. And running this on our actual input, we get our answer of 2732. Looking now at part 2, we have a special mushroom that needs to fit, that can fit in any crate, but can't be packed with anything else and needs a bit of air to survive. And so we want the smallest possible set of exactly 20 crates. Basically, we want a set with 20 crates that has the smallest possible sum. And so again, noting that a set is really just a set of deduplicated elements. If we sort all of our crates in order and remove the duplicates, we can form a set out of any 20 of them in that order. And so obviously the smallest set will just be the first 20 elements. And so once again, we take our input, split it, turn them all into integers, deduplicate the values, and then we can sort the values, take the first 20, and take the sum. And that works fine to give us our answer, or sorry, the first 20, not removing the first 20. That gives us an answer just fine. If we want to make this a bit more readable, we can do something like this. We can do something like that, but once again, up to you how you want to represent it. One thing to note is that sorted works on any iterable, so you can sort a map directly, but it always outputs a list. So we are sorting a set here. One thing to note about sets is because they're unordered, you can't get the first 2 elements of a set because that doesn't work at all, because there is no concept of first or last items in a set. So if you want to do that, you'd have to convert it to a list, but in that case, there's no consistent ordering. However, when we apply sorted to a set, it'll output a list of the values in order. The reason we don't sort the map here is because we still want to deduplicate the elements, because again, you can't put both of the crates with size 49 into the set. So once again, up to you what you think makes the most sense in terms of representing the solution. And trying this on our actual input, we get our answer of 269. Finally, for the last part, we need to pack the empty crates. So we have a bunch of crates left over after we finished packaging the mushroom and the other goods, and we want to pack these crates as efficiently as possible into as few sets as possible. What we can note here is that if we have any set of crate sizes that are completely distinct, we can always put them into one set by just putting each crate, the smallest crate into the second smallest crate, and then put that one into the third smallest crate, and so on and so forth. And so each time we can remove one of every size that shows up, which means that the total number of sets is the maximum of the number of times each crate size shows up. I'll explain this a bit better. Basically, we see in this example that there are 3 crates of size 49. We can't pack that into any fewer than 3 sets because each set cannot contain 2 crates of the same size, which means that we need at least 3 sets. We also only need at most 3 sets because every crate size that shows up can be put into a set at exactly once, which means that since none of the crates show up more than 3 times, we can always put one of them in each of the 3 sets. And so the answer to this one is to count the number of occurrences of each crate size and then find the maximum. So what we can do is we can keep a count map. One thing that's also important to note is that empty braces indicates an empty dictionary, not an empty set. If you have a set with values, you can use the braces like this. But if you have no values, then it'll actually be a dictionary. So if you want to make an empty set, you have to call the set constructor like that. In this case, we want an actual map. We want to store a dictionary from each crate size to the number of times it shows up. So now what we can do is loop through each of the sizes and then add to the count. So there are two ways of doing this. I'll show you the way I don't prefer first. What you can do is check if the size is not currently in the count dictionary. You set it to 0, and then increase the size count by 1. So let's print out the counts just to see where that takes us. We get a dictionary here of all of the counts. So you can see that the crate size 52 or 57 shows up twice. Crate size 49 shows up 3 times, etc. Equivalently, you can also do this, but I find that to be a bit more confusing. And the last way that I personally prefer is to use the get function. So .get obtains, it's basically, if you do x.getY, it's the same as doing x, the yth item of x, but instead of erroring if it's not present, it just gives you null, or in Python's case, none, unless you specify the default value. So what we can do is count.get size 0. What that says is it gets the value of size in the count dictionary, or if it's not present, it gives 0. And so we can do count size equals count.get size or 0 plus 1. What this basically says is set the number of times we've seen size to either the current number of times we've seen it plus 1, or if we haven't seen it before, then the number of times we've seen it is obviously 0. Finally, to get the maximum occurrence, we don't care which crate size shows up the most, we just care which frequency is the highest. So we can do count.values to get an iterator of the values, which is basically the number of occurrences without considering which crate size it corresponds to. And then we can just get the maximum of all of those to get our answer for part 3. And running this on our rather large actual test case. Did I do something wrong? Okay, it looks like the input just got truncated by my terminal. So if we dump it into an input file, then it works just fine for part 3 as well, giving us our answer of 2,242. So, interesting problem overall, mostly made quite straightforward by Python's sets. If you don't have access to sets, let me just quickly go through part 1 and 2 again. Part 3 doesn't involve the use of sets, so that's fine. If you don't have access to it, what you can do is if you sort the items, then you can just look for then all of the duplicates will show up next to each other, and so you can just keep track of it like that. So what we can do is sizes equals list not input dot split. I guess we can sort this. And then we can keep track of the last item we've seen, which we'll say is initially -1 because all the crate sizes are positive. And then we can keep track of the total for size and sizes. If the size is different than the last item we've seen, we'll add it to the total and update the last item we've seen. And so that works just fine for part 1 as well. For part 2, we can do something similar. Actually, we can do basically the exact same thing and just end once we've seen 20 crates. So that works. Or, sorry, I forgot to switch to running part 2. That works just fine for part 2 as well. So if you don't have sets, you can do something like this. It's still relatively straightforward, but Python sets certainly make it a lot easier. And so that's it for today. Once again, another very interesting problem. Looking forward to see where the story continues with this. And thank you for watching.